So I put together a little example to show you Javadocs, and so that you can actually see what it does, see how it runs, see how it works, and then you'll have a better understanding, I hope. And I put this project together. It's called Javadocs Examples here, and I put it out on the bhacker.com website. And it is, and let me show you another thing as well, because some of you have been going through and looking at some of the examples, but not probably knowing where I've been getting them from. They are in the course materials subdirectory of the class, and they are listed at the bottom. So you might notice that we have some examples here, swing examples from the notepad. Javadoc examples is from lecture number 10. That's what I'm going to show you in a few minutes. And then collections and the rest of that stuff. So it's all in here in the lecture examples subdirectory, which is a subdirectory of the class itself. So let's take a look. This particular program is a stack, and doesn't really do anything. It just has a bunch of documentation in it, really. This is Javadocs. So it's going to create, so we're going to create Javadocs here by putting in messages, notes to self inside of the code. And we're going to select, and this is using Eclipse, by the way. And I've actually created this already, so I'm going to delete it. There's a directory here called docs. I'm going to delete it because I'm going to create it again so you can see what happens here. So this is a regular old Java project that I created, and I added a class, and I'm going to call the class stack.java. And in the class, I've got this one, public class stack, and in here at the beginning of the stack in front of the class, I've put some documentation in here, and I'm using this, as I mentioned before in the lecture, this notation to tell you that this class represents a last in, first out stack of objects, and actually is a stack. So it actually does work as well as a stack. And the author is Barbara Hacker, the version's this. Note that this version is not thread safe. Yeah, it's not really thread safe at all, actually. But it's not really, you're not looking at this for the code, you're looking at the documentation that's in here. So directly preceding the class at the class level, I've stuck this Javadoc in here. And there's nothing to really automate it. You just kind of just put it in there and you type it in. There's tools that you can actually do for plugins that will come in and say, document this. You just type it all in and it inserts the code for you. Or you can type the code in there. So I don't have a plugin installed. I just basically actually just took this and put it in here and said, okay, auto-generate the stuff for me. So here we have the push method, and we have a description about it with some parameters. We have these tags, as I mentioned before. The tags in here, this is the item that is being pushed. Pushes an item onto the top of the stack, yada yada. Here's one that says pop on it, removes the item from the stack. Another tag for the return, so the object at the top of the stack, the exception that's going to be thrown here in terms of no such exception, no such element if the stack is empty. And notice how you've got like two spaces here. I'm kind of spacing it out a little bit. What you're going to do is essentially look at the syntax, and that's what that lecture is all about, showing you the syntax and all the different tags that are available for this. We'll also get, you know, as in terms of reiterating the point and refreshing your memory from the last lecture I gave you, that these descriptions are immediately preceding the methods. So. And you don't have to do this for any of your programs, by the way. However, when you get into the real world, it's an easy way of creating documentation. So here's the pop method, returns the object off the top of the stack. Here's the peek method. Here is empty. It tests to see if the stack is empty, yada yada. So note that within the Javadoc comments, there's also additional information that you can give. As we mentioned before, these were the tag elements I'm talking about, like return, exception. Return is used to give the intent of the value returned by the function. Parameter gives the intent of the input parameter. Obviously, exception, data. Anyway, you could read through all of the different tags. We're going to generate this so we can kind of see why are we doing this. We're doing this because eventually what we're going to want to do is generate it. I put on the top of this example, I put the instructions for how to generate it. Different versions of Eclipse might have different menu option locations. Used to be on the bottom. In fact, there is a way of getting it on the tab. You press the tab and you go, create Javadoc for me. I'm just going to run it from the menu because I lost my tab. don't know where the tab went, and may not be supported in this version, who knows. All you have to do is open up the document, you go to File, and go to Export, which is not very intuitive. You wouldn't think that it would be in the Export directory, but, or, you know, Export menu option. So you go to Export, and then lo and behold, instead of exporting it like a jar file, which you can actually do if you want to create a jar out of it, and you do that, so you run the file as, you know, all those classes are going to get stuck into one. Didn't really cover jars because it's kind of just a way of compressing everything, putting all the classes into a single file, then taking and uploading the file to your website, or taking and uploading it and running it from the file itself. Just like you're running a regular old program, all of your classes, all of your packages are in jar files if you haven't noticed it. So if you install something new, you just copy a jar file into a location, and you're basically, you know, all of a sudden you've copied an entire directory of information. Sort of think of it not like an exe file, but more like a zip file, but for Java classes that are inside of it. We could create a runnable jar, which is sort of like a zip file, excuse me, like an exe file, like a Windows executable file. But anyway, Javadoc is the option that we're interested in selecting at this point. So I'm going to go ahead and select Next, and it's going to put it in this directory here. Excuse me, it's going to run the command here. So if I wanted to, without using Eclipse, I can run this particular command from the system prompt. And the system prompt is actually the command Javadoc space the name of the project, or the name of the class file, and it actually automatically creates it for you. So you don't actually have to use Eclipse for this. You can run it on a command line, but most of you are using Eclipse. And I'm going to stick it in here. The destination is your choice. You don't have to stick it with the project. You can stick it outside of the project. But this one is going to stick it inside a directory called doc. I deleted it, so it doesn't exist here. So it's going to hopefully recreate it for me. And I pressed Finish. And lo and behold, you just saw it hopefully populate a few minutes ago. I have the doc directory back, and it has a fresh version of my Javadocs. If I don't do this, what will end up happening is the next time I run it, it'll just overwrite it. And this is the interesting part. So in here you can see all of the support files that are for the doc. Your main Javadoc is an HTML file with the same name as the class. So it's this one right here. Automatically has a style sheet associated with it. You can change the style sheet, because what you've really done is created, and I've double clicked on this right now actually. What you've really created, and here it is over here, is a HTML, updated HTML version that has all your comments in it. So this might look familiar. The class, the stat class represents a last in first. That's my comment that I put in there at the beginning. The version, the author, and I use the author as a tag in here, so just to compare this back and say, well, how did we get that? How did that end up in there? Up at the top here it said author, and it said version. Those tags showed up in here as the author and the version, so now we have version colon author colon. So most of those tags show up, so I'm going to see parameters, I'm going to see exception in terms of categories. And in the object itself, so on the pop, if I, or actually peek, if I clicked on the peek, but the pop would be the same. I threw a, I had an exception, so I have a throws. I have a return tag put in there, so it's going to show me this category. And so this is all of the information that I put in the comments. So what it does is it automatically goes through, reads all those comments, puts it out in a nice little formatted HTML looking thing like this one here. All of them look the same, but you can change the CSS if you want to change the colors and add some graphics to it. If you go online, you'll see Javadocs for practically everything out there, because it's automatically generated and it all looks the same. So, and you're more than welcome to use the same CSS and the same thing as everybody else uses, and put this out on a website to document your program. Are your users really going to look at it? Probably not. Are other source code people going to look at it? Yeah. So, you know, 10 years from now, when you're no longer with the company, someone can come in there and go, what was that stat class? Oh, it was written by Barbara Harris. Oh, it was version number 1. Okay. Look at that, the pop method, the peek method, you know, and learn all about your program, essentially, whatever kind of bits and pieces of information you're left behind in terms of the documentation. And if you, it's kind of common, actually, to keep it as part of the project. So in this particular case, if I had this stored in a repository, I zipped it up. Like when you download it, you're going to get the last Javadoc that because I forgot to delete it before I zipped the file up. You're going to get that, and so you can open it and go, what is this here? You can find out what it was, and all the documentation, because this is just one file. Normally you're going to have like dozens of files that are part of the project. You can put it all together in one Javadoc, and you can have all of this stuff documented, theoretically. So it's internal documentation in terms of the source code. That's your Javadoc exercise for today. Let's take a look here. Doing good on time. So I'm gonna. Can someone tell me when it is? 6:45? No, 6:45. No, tell me when it is 6:45. Okay, good. It's like, can you tell me? Yes, it's 6:45. No, it's not. I'm gonna try and attempt to finish one more part of this lecture. Hopefully, we'll see how far I can get. Might be able to get through it all. We talked about, we got through the garbage collection, I believe, as well. So this is lecture number 10, which is sort of the last lecture of the course, but I still have more information to give you on Wednesday if I do finish it. If you're missed it, or if you're interested in looking through the details of the comments, this lecture has the syntax, what you're looking at here, in terms of the line and the asterisks for the formatting. And then some of the tags, and this is going to use a slightly different method. It's going to have C in there, and so we can actually create links and things, hyperlinks to different sections of the document, to different things. Like one object can actually have a link to another object, so it's because they're sharing a particular functionality or doing something with it. We saw the return and the parameters, and these are the different tags that are available. The throws and the exceptions we saw actually as well, depreciated author version. And then if you were typing it in on a DOS prompt, you type in Javadoc, essentially, in the name of the file to create the Javadoc for it. And you can just do it for all of the files, actually, for each one of the classes, and then stick them all on a website or something. Package documentation as well. Looked at that. Unlike the comments, packages are not defined in source code files, so you can generate different package comments in the same fashion. So you'll need to add package.html to the file package directory, and you can essentially do the same thing at the package level, but done in a slightly different fashion. So we have contents of the package itself, the body, all in an HTML format. The body tag is going to be essentially containing the meat of the depreciated, the author, the version, all the information about the package itself. And there are no package questions, and there's no Javadoc questions at all on the final exam. So, because I told you what was on the final exam. Usually I have someone asking me, is there any questions on the package Javadocs? Like, nope, there isn't. So, let's see, garbage collection. This is on there. We know that we have new, and I don't know if I covered this or not, so I'm just going to kind of briefly summarize it. We know that there's new, but there's no corresponding delete because we don't have to remove anything. We can allocate, and the Java JVM deallocates for us automatically. So it's a collection. There's no intervention, but collecting garbage will take some time. So the JVM does slow down the operating system a little bit because it is doing automatic garbage collection. So a lot of people say, well, the Java program runs a little slower than the C++ program. It actually does. Slightly. Most of the time you can't notice it. In fact, if you're on a fast processor, you're not going to notice that much of a difference. So there's also no guarantee that you're going to actually have everything garbage collected correctly. And there's no guarantee you're never going to have any memory issues. You can still have memory issues. You can still run out of memory. You can still fill up the memory. And it's not a garbage collection issue. It's the fact that you filled the memory up. It's the nature of your program. It's kind of like, in the old days, you could create a recursive function in C++ and pretty much crash the process. You can do the same thing in Java. You can allocate like with a recursive function and have the same problem. Because your garbage collection, if you're still referencing it, and it's not going to get garbage collected, eventually you're going to run out of memory. So, nested classes and interfaces. This is the new part. So, because I know I didn't cover this. So classes and interface can be declared inside, which is what nesting is all about, inside of other classes and interfaces. Remember when I created a dinosaur that had babies? The dinosaur actually created instances of dinosaurs. And that would make a nice reality show. Anyway, PBS store. Anyway, in terms of the abstraction, but That would be a class object that's inside of another class object. You can also implement classes inside of classes and interfaces inside of interfaces, either as members or within blocks of the code. So we have static nested classes and interfaces. So we know what static means, hopefully, class level, not instance. So we have a class, a nested class interface, which is declared as static. Acts just like a non-nested class interface, except that its name and accessibilities are defined by its enclosing type. So when we put something inside of something else, we're referencing it from the particular object space that we have enclosed it in. So static nested types are members of their grouped enclosing types, and they can access all the data members and everything else that's inside of the private ones, even the private ones inside of it. Because if you're inside of a class, you have access to that class. It's just the private stuff is not accessible outside of the class. So if you want to have a class, let's say for example you have a checkbook program, and inside of the check class you have two instances of objects that are created that are, let's see, inside of the entry class as a registry. You have different types of things that you're putting into this registry. This is an old concept. Nobody actually does this anymore, do they? Keep track. Okay, so in the old days, when you wrote a check, you had a book, like a paper book. You guys remember this? And you wrote in there, check number 502, made out to so-and-so for this amount.
They have no's, though.
Everyone does it online now. But if you're going to write a program that does that, like some of the entries are debits and some of them are credits. So you can make an entry, and then inside of that have an interface for a debit, interface for a credit, or in subclass, which would make a nice good example of this type of implementation. Because if you'd nest them inside, they'd all have access to the registry entry, but they would be using different interfaces, or depending upon what they were. So anyway, long story short, that's kind of a convoluted example that you could use this concept for. But the hierarchy is not outside, it's inside, so anything inside that's nested has access to private members inside, because it's part of that class, it belongs to it, versus the outside. So you nest for grouping, to keep liked objects that are working together. Also, if you nest a class inside of a class, you're doing, in fact we've seen this already actually, one of the data structures had a linked list that had a node that was, class node, public class, private class node that was inside of the linked list class. And it's done that way because it doesn't actually have any reason to be outside of it. So in the linked list we have instances of the node objects that are being created, and the class itself is defined inside a linked list. So there's that relationship. So the linked list node can share information and back and forth. And it's, I don't know, for abstraction it kind of makes it more sense to nest it in that particular case as well. So that's another example. They serve for structuring, scoping mechanism for logically related types. Because when you create a class, you're actually creating a new type. A new type person, new type linked list, node. Those are data types. So if you have logically related types, you nest them because the abstraction is supposed to be a little bit easier. You don't have to, however. You never actually have to nest anything in your entire programming career. You can have everything all at one level. But then if you do that, then the node can be used for anything. So it's more of a generic node instead of a special node that's only accessible by the linked list class or something like that. So static nested classes, if the class is nested in an interface, it's always static. So you basically omit. Here's an example down here. This is the bank account kind of concept. Okay, so we have a public class bank account with two private data members, public static class permissions. So it's an object that's inside of the bank account that's going to give permissions to certain people. Boolean can deposit, can withdraw, can close type of permissions. So static nested class serves as a mechanism for defining logically related types inside of the class. Instead of creating the type and then including it inside of the class, you're just going to create it in the class as well, which could have pros and cons to it depending upon how you're using it. So you can extend other classes, implement other interfaces, extend anything you want. And it's all accessible inside of the class. So the scope inside a bank account, well, it includes permissions. which is another class. So if you haven't gotten the concept, we have this class declaration, and then inside we have another class declaration. So far in most of the examples I've been showing you, it has just one class, and then we have another class, and we have another class. This is a class inside of a class, which is what's called nesting. So it's not a hierarchical thing. So code outside of bank account must be bank account.permissions, which is, so you have a class name dot a class name. So you can actually run permissions to set Boolean permission, can deposit, can withdraw, by going from a class into another class, into another class, into another class, dot some data member or some method that you're going to run on it from a class level. And then we also have nested interfaces as well, same concept. So it's always static as well, since they don't provide implementation. Because an interface doesn't have an implementation to it, there's no need for it not to be static. So inner classes are associated with instances of its enclosing class. So every time we create a bank account, in this particular case, we have public class action. We have public class, or we have anything else that might be associated inside of it. The instance is inside of the instance. So if we take a create through inheritance, and I'm going to show you two separate things here. If we have a person who's an object, and then we have an employee. Employee can cast a person, and we have two different levels, or two separate object identities, but a person also has, an employee also has a person, also has an object inside of it. And it has that is a relationship that I've been talking about so far. All of the other examples that we've seen in the class have been that format, where there's a hierarchical relationship between it. Now what we're saying is we have a person, but instead of, we have an employee as an example, and then inside of employee we have action. We have bank account in this particular case, we have action inside of the bank account. The class belongs to the other class because it's nested inside of it. We don't cast object types, and we can't get rid of it. It's part of us whether we want it or not. So every bank account has another object action inside of it that's instances of the same object. So it belongs to that object, so we can't get rid of it. So as long as we're a bank account, we're always going to have that action in there. Whether we use it or not doesn't really matter. So a lot of people don't like to nest classes inside of classes because you're going to get both automatically, whether you're going to use it or not. It makes a big, heavy class out of it. So if you nest a bunch of stuff inside of the class, and all that stuff is owned by the class, you're exposing the data members, you're exposing the methods, you're sort of breaking the inheritance concept in terms of the private, protected, and access methods, and you're creating one huge object. You could essentially run out of memory if you have all these huge objects that you're creating that have all of these other classes inside of them. So it's done sparingly, because what ends up happening is if most of the time if you're nesting too many internal classes, you probably should be thinking about inheritance instead. But in some cases this is not inheritance. The bank account uses an action object. It's not inherited. There's no relationships in terms of super and subclass relationship between a bank account and an action. It's an action that's being performed within the bank account. So the concept doesn't come up that often. But it's kind of like one of the reasons why I created the baby dinosaurs inside of the dinosaur. But I was creating objects. So those were objects of dinosaurs that were inside of the dinosaur. If I created a class, and I called it eating class or drinking class or something, I made a totally separate class out of it, and it was only used by the dinosaur, that would be appropriate. But if I put that class outside of the dinosaur, then that class can be used with any other class out there as well. So there's a difference between making the baby classes, baby objects. Those are making instances of objects. Also know that you can create classes, interfaces, abstract. Everything can nest inside of it. And that is the entire lecture. Because what ends up happening throughout this lecture, and let me show you what's in here if you're interested in this. What you're going to see in here is all the different exceptions and all the different scoping and all of the different hiding rules. And every time I give this, and we also have the anonymous inner class as well that doesn't actually have a name to it. It's just that's even a lighter weight object. it's a class that's inside of a class that doesn't serve a purpose as a separate object. It's only being used inside of that class. So nesting interfaces inside of interfaces, multiple interfaces. So comes in purpose for creating a bigger structure and breaking it down into smaller components, essentially. Usually in the past I've gone through all of this stuff and most people look at me like I'm speaking a different language. I will leave this to you, and I already told you it's not on the final, so you don't have to worry about it. I will leave this to you as extra reading, actually, because if you're really interested in it, it's actually everything you know so far, but all of the different rules in terms of scoping. Because sometimes it works in, oh, this is really good timing. Sometimes it works in your advantage, and then sometimes, you're thinking like, wow, can I nest an interface inside of an interface? It's just like a function inside of a function. You can put a function, a method inside of a method, a class inside of a class. But be careful of the logic. I'll leave you with that. Make sure that the class is actually related and there's a purpose for doing it. Some of my examples actually have classes nested inside of other classes, but I call them lightweight classes. It's kind of like action for bank account or something. It's kind of serving a purpose, but it doesn't really have a functionality outside of that. Okay, we still have a lecture on Wednesday, although I'm not going to see very many of you. Here, let me stop this video. We still have a lecture, though,